Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. This one instruction cost thousands of marks across last year's papers, not because the algebra was hard, but because students forgot the habit examiners want: write the chain of equalities clearly and finish with a final statement. What do show that and exacts mean? They're asking you to present a precise algebraic chain. Start from one side, apply valid algebraic steps, and reach the expression. The examiner doesn't want mystery. They want to see your reasoning. Let's work through this step by step. Here's a worked example you'll hear across many papers. Show that 2x plus 3 squared minus x plus 1 times 3x plus 5 equals x plus 2 squared. Step 1. Expand each product. Expand 2x plus 3 squared to get for x squared plus 12x plus 9. Expand x plus 1 times 3x plus 5. By distributing x times 3x plus 5 gives 3x squared plus 5x. 1 times 3x plus 5 gives another 3x plus 5. So combined that's 3x squared plus 8x plus 5. Step 2. Subtract the second expansion from the first. So we write for x squared plus 12x plus 9 minus 3x squared plus 8x plus 5. Now collect like terms. For x squared minus 3x squared leaves x squared. 12x minus 8x leaves for x. 9 minus 5 leaves 4. So the result is x squared plus for x plus 4. Step 3. Recognize the quadratic x squared plus for x plus 4 is a perfect square. It factors to x plus 2 squared. So we've transformed the left-hand expression into x plus 2 squared, which matches the right-hand side. At this point you write a final line. Therefore 2x plus 3 squared minus x plus 1 times 3x plus 5 equals x plus 2 squared. Box that equality. That's your finish. Now why does each step earn marks? On a typical 3-mark show that question, the examiner is looking for method and accuracy. M1 for a correct expansion or correct algebraic manipulation, M1 for correct combination of like terms or rearrangement, and A1 for the correct final statement or exact simplification. Examiner tip: label your steps. Write expand, then your working, then collect terms, then your simplification. Examiners scan for a clear method. A labeled chain of equalities makes it easy for them to award method marks, even if you make a small slip later. Students sometimes reach the simplified expression but forget the final statement that connects it to the question. For a show that you must explicitly write the equality the question asked you to show. Writing the raw simplified expression without the therefore line can cost you the final accuracy mark. So box the statement. It's a small habit with real reward. Quick win. A 10-second routine you can use in every exam. 1. Write the target from the question at the top. 2. Label each step, expand, simplify, factor, short labels. 3. Box the final equality and write hence shown or therefore shown. 4. Substitute one easy value into both sides. For our example, use x equals 0. Left-hand side, 2 times 0 plus 3 squared minus 0 plus 1 times 0 plus 5 equals 9 minus 5 equals 4. Right-hand side 0 plus 2 squared equals 4. They match. Quick sanity check done. That substitution trick takes 10 seconds and catches sign errors or missing constants in most show that problems. 3 frequent pitfalls and how to fix them quickly. 1. Skipping justification. Fix it by writing the expansion or the factor explicitly. 2. Sloppy rearrangement or sign errors. Fix that with a substitution check I just gave you. 3. Missing the final statement. Always end with therefore or hence shown and box the equality. Mini practice for you now. Try this one. Show that x plus 3 squared minus x minus 1 times x plus 5 equals 2x plus 14. Pause the episode if you need to. Write expand and show both expansions. Collect terms for the subtraction and end with therefore x plus 3 squared minus x minus 1 times x plus 5 equals 2x plus 14. If you want to self-mark, give yourself M1 for a correct expansion line, M1 for correct collection of terms, A1 for the exact final equality. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable checklist for show that and exact questions at workbook.jcacademyline.co.uk. Stay curious.